yearn to fathom the cosmos. I follow cosmological data and discoveries. But are data and discoveries sufficient? Do we also need new ways of thinking? That's why I seek surprise. Watch when current theories are challenged. That's also why I focus on something called the Anthropic Principle. The Anthropic Principle claims that, in the universe, our presence as observers compels conditions for our presence. The claim is controversial. Some say that the Anthropic Principle can guide scientific discovery, others that it can thwart it. Some say the Anthropic Principle is only trivially true, almost a tautology signifying nothing. Others that it conveys deep insights. How come such divergence? Is the Anthropic Principle misunderstood? What really does the Anthropic Principle claim? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. For decades, I've tracked the Anthropic Principle as a philosophical argument. What could follow from it? A more special role for humanity in this universe? Or an even less special role in multiple universes? Those are the stakes. I hear of a conference on the physics of fine-tuning. And because fine-tuning is the claim about the apparent special nature of our universe that drives or justifies the Anthropic Principle, I decide to attend. The conference is in Crete, Greece. The rolling ocean vistas are dazzling. I take care not to soften my skepticism. The Anthropic Principle seems such an odd idea. Maybe a historical perspective can help. Attending the conference is an Anthropic Principle pioneer. I seek him out, cosmologist Bernard Carr. Bernard, you were there almost from the beginning when the Anthropic Principle was coined by Brandon Carter. Give me the history of the Anthropic Principle, how it works, how it should work.
Well, first of all, one has to make a clear distinction between what is called the weak Anthropic Principle and the strong Anthropic Principle. Now, the weak Anthropic Principle merely says that given the laws of physics and the values of the physical constants, there is a selection effect on when and where observers must exist, which just comes from pure logic. And so, for example, we have to live close to a star. We know we have to live at a special time in the history of the universe, just a logical necessity. Now, much more controversial was the strong Anthropic Principle, which, as Carter defined it, was the fact that there are relationships between the physical constants themselves which are required for us to be here. And what Carter did, and myself and Martin Rees did in our later paper, we collected together all the large number of these unexplained coincidences between the constants of nature, which weren't explained by conventional physics, but seemed to be necessary for the existence of observers. The way that he defined the strong Anthropic Principle, and the way that myself and Martin Rees defined it, was simply in those terms. Later on, the term was used in a different way in the famous Barrow and Tipler book in 1986. It was defined more in terms of the condition that the universe must be such that life can
A different
can
concept of must.
So a different concept of must. It introduced a sort of teleological aspect, and I think that's what caused some confusion in the literature, because after that, people again started using the term in different ways. The term anthropic itself, though, which means anthropos, the Greek word for man, was, I think, also very unfortunate, because it's really nothing to do with the presence of human beings in particular.
So on both sides of that question, how has the Anthropic Principle been used properly within physics and cosmology, and how do you believe it has been used inappropriately outside of it?
Well, there's essentially three types of interpretation of the Anthropic Principle. One interpretation is the multiverse interpretation, which simply says that there are lots and lots of universes with different values of the constants, and we just happen to be one of the ones which allows life to arise. And the second interpretation, for example, is the one that comes out of quantum mechanics, the idea that maybe consciousness collapses the wave function of the universe. You have the Big Bang and the universe evolves into consciousness, into brains, which then reflect back on the Big Bang, and you sort of get a closed circuit and the universe comes into existence. And the idea was that in some sense, the consciousness itself was bringing the universe into existence. Well, most physicists also regarded that as far too metaphysical. But the third explanation, of course, is even beyond that and says, well, the reason the universe is fine-tuned is because there is a fine-tuner, which some people might want to call God. And so you have this idea that maybe there is like a parameter space where all the physical constants exist, and in some sense God had to use a pin to choose the values which would allow life to eventually arise. Now, obviously, that's a theological explanation, and physicists were very unhappy with that. But depending on which explanation you favor, it tends to depend on which of the interpretations of the strong anthropic principle you have. And those people who want to adopt a theological interpretation of the fine-tunings, they obviously tend to have in mind a version of the strong anthropic principle which is more teleological in nature. Whereas the people who want to interpret the fine-tunings in terms of the multiverse, they don't have to have any teleology at all, and they just have to have the concept there is this space of other universes.
I get it. For starters, I must distinguish between the weak and strong anthropic principles. The weak anthropic principle states the obvious idea that the universe must be consistent with the evolution of intelligent life, because intelligent life has obviously evolved. And the strong anthropic principle states that the universe must give rise to intelligent life. The weak anthropic principle is simple logic. If the values of physical constants in our universe were not consistent with the existence of observers to measure them, there couldn't be any observers. Obvious, sure, but is it also oddly insightful? Frankly, I can't decide. Can it trigger new kinds of questions? I'm perplexed. However, it's the strong anthropic principle that rattles my brain. I'd like an aura of purpose, a teleological imperative, such that life and observers must be part of the work of the universe. But I fear false friends. That's why I pay attention when most scientists take seriously only the original, non-purpose-driven anthropic principle, and even then, usually reject it. To find out why, I speak with Oxford astrophysicist Pedro Ferreira.
I have to put my cards on the table. I'm not a huge fan of the anthropic principle. I think it ruins the mood, basically. There is this fantasy that we have, that we are after the final theory, the fundamental theory, the theory that will explain everything from a very few simple physical principles. And I think that's a good guiding principle. I think we should always try to figure out the simplest explanation for what's going on. The problem with the anthropic principle is it can stop you doing stuff. Anthropic principle basically is things are what they are because they are what they are because we exist. Often when people say they're using the anthropic principle, they're not using the anthropic principle.
How so?
A very classic example is a few decades ago, Steven Weinberg predicted the value of the cosmological constant from the anthropic principle. And the line of reasoning was, for us to exist, there have to be galaxies. For galaxies to exist, the cosmological constant must have a certain value. Now, the us existing is completely irrelevant in this. The argument is more, there are galaxies. For galaxies to exist, there must have been an anthropic principle. Yes. There's no anthropic linchpin here. There's an observational fact, which is there are galaxies. And if there are galaxies, he made a claim that there should be a cosmological constant. But anthropics is irrelevant.
Well, anthropics is sort of the natural derivative of the existence of galaxies. It goes the other direction.
The fact that we exist or not is irrelevant from the point of view of existence of galaxies.
Certainly. There could have been galaxies without us, yes. But there couldn't be us without the galaxies.
Sure.
And that's the point.
Yeah, well, no, I think there are observational facts, right?
Made by observers.
Yeah, but I think the existence or not of observers is kind of irrelevant.
I think it's a distinction without a real difference, because the only way we know those things is the existence of observers. Us are derivative from that. So to get to that, we have to be here. So,
but you could then say that anything we predict or measure, the existence of the Higgs is predicted because of anthropic reasoning, right? There is this, there are electrons. We wouldn't exist because of their electrons. Particles have masses.
Everything that would be needed as a precursor for us would be subject to that concept.
So do we repackage all predictions in physics as anthropic predictions?
You could. I don't think the people who do anthropics are saying that's the first line of defense, but rather, if all else fails, if you can't get a more fundamental theory, that's certainly a constraint that you can use.
It's not a useful research tool in that you could do that and you shut down the discussion, or you continue looking, you follow other avenues, you try and find a fundamental theory.
But there are some things that, like planetary orbits, that there's no fundamental theory.
Absolutely true. And so I think one should try not to invoke that argument until one has reached the point. The point is, we now know that the planets in the solar system are where they are because of, it's a random effect. We even know that they're not stable, but we knew that because we pursued, Newton's theory of gravity, and we went for fundamental explanations. That's a more productive route than just stopping.
Pedro and I pretty much agree. We should focus on finding fundamental theories to explain values of physical constants. At the same time, I do not think it contradictory to use anthropic reasoning in parallel to seek potential insights, such as ranges of values for physical constants and how they might work together. What can science say for sure? I speak with an astrophysicist who emphasizes observations and experiments for precision cosmology, the chair of Harvard's Department of Astronomy, Avi Loeb.
Avi, when I think about the anthropic principle, I oscillate between the two extremes. On the one hand, it sounds utterly trivial. The other extreme, it's one of the most insightful probes to lead us to a deeper understanding of reality. It's either one of those two extremes.
It all depends on whether there is this notion of the multiverse, where things are realized in many different ways, as to whether in our region of the universe, things were arranged to fit our existence. And that will determine, this notion will set the stage for whether the anthropic argument has relevance for explaining anything about our universe or not. We tend to believe that we are at the center of the scene, but this may be an illusion. It depends on how common is life under different circumstances in the universe. We may believe that things were arranged based on the anthropic argument just because of our ignorance of other possibilities for life elsewhere right now. So instead of the anthropic, it may be life-centric in many different ways that we currently do not realize. And so our notion of the anthropic argument may be misguided at the moment.
If you start with the multiverse, I understand that position, but the history of the explanatory process, even though multiverse comes out of the physics of inflation and many worlds of quantum theory, it starts out differently. It starts out with a recognition that there is fine-tuning in our one universe, and then that cries out for explanation. It just seems so absurd to have such fine-tuning. It could be a brute fact. It is what it is, like it or lump it, and there's no explanation. That's very unsatisfying. There's a theological explanation, which some people find very satisfying, other people find completely unsatisfying. And the multiverse, in terms of an explanatory process, how do you analyze it?
Well, the way I view our existence is that we are probably just an afterthought. We happen to exist right now, but there is no special significance. I would think that the actors in this play are not particularly important. The chemistry of life is just a byproduct of circumstances that were generated in our observable volume of the universe. It's possible that there are other volumes where the circumstances are different and nothing that resembles life as we know it takes place there. So in a way, you might argue that we can explain our existence based on some principles or based on the fact that life exists in some regions and not in others. But I don't find that a particularly important question. What I think is the most interesting is to understand how this huge history of the universe, with all of its complexity, evolved, and what are the underlying principles that controlled its evolution, and just appreciating that beauty by itself, as if you're looking at a beautiful work of art. It has to do with the complexity, the richness, and the aesthetic pleasure that you get from looking at it.
And that does not need human beings, it does not need life, it just what it is?
It's just enjoyable to look at it and study it, and that's what I do as an astronomer.
Avi links the anthropic principle to the so-called multiverse, multiple universes, which most physicists accept as the natural outcome of current theories, but which some reject as outside the domain of science. Now, because the multiverse is essential for understanding both fine-tuning and the anthropic principle, I need to pursue these three big ideas at the same time. I speak with an expert on galaxy formation and evolution, a cosmologist at the University of Edinburgh, John Peacock.
For me, the term anthropic principle isn't terribly helpful. I'd probably prefer something like observer selection, universe ensemble, or even the multiverse. I think all of these are preferable terms. So I think Brandon Carter, back in the 70s, when he first introduced the term, probably had a clearer definition than some of the detours that it's taken along the way since then. I'd rather we could just sweep all that past discussion away and start with a clean slate.
Okay.
So we know things that we didn't know then, like that there's a non-zero effective cosmological constant in the universe, that the Higgs exists and it has the strange value of the mass that it has. You know, all these things have built up into a pattern of extra evidence that provoke us to look for explanations beyond just saying, well, the universe is as it is, take it or leave it.
Okay, so how does the anthropic principle articulate with fine-tuning?
I mean, fine-tuning, I think, is anything where you look at the structure of a theory, which can be its global properties or the values of parameters within it, and you think, I would prefer that if this arose out of a simpler construct. And the simplest thing to focus on is parameters that take values that are so extreme compared to what you might think is a natural value. So when you have a very small but non-zero number, that's a puzzle that calls for an explanation.
And when there's a great range between parameters that are in the same kinds of categories, that can also look strange.
Well, it can be the other way around. So here's a strange coincidence that the densities of normal matter, such as you and I are made of, baryonic matter, and dark matter in the universe are more or less equal. Although our best guesses for the physical mechanisms that leave these residues from the Big Bang, they're completely unrelated pieces of physics. There's no reason why these two numbers should be approximately equal. At the other end of the spectrum, you've got the fact that there's an effective vacuum density. And you can try and calculate this from first principles using quantum field theory. And depending on how you do it, you've got a number that's at least 50 powers of 10 larger than what we measure. But it's not zero. That demands a mechanism. And if you have no mechanism, the only solution that you can reach for is to say, well, this is so incredibly unlikely. It's like winning the national lottery. So people win the national lottery every day, but the only reason they can do it is that there are millions of losers. So the universe has won the national lottery of the cosmos. And so you're naturally driven to think about the possibility that there could be an ensemble of universes out there, the multiverse, with different physical properties, and then ask, observer selection should drive us to inhabit only a small subset of these.
And therefore the selection effect works, but in this whole process you are abandoning, in a sense, the concept of an anthropic principle, but just looking to the selection effect as the multiverse.
But you see, but to me that's what the anthropic principle always was. I mean, some people try to dress it up as a kind of element of almost inevitable destiny, that's stated as the universe must be such as to produce life in it. And I think that the whole idea of observer selection in the multiverse is the complete antithesis of that, because what you have is this actually terrifying picture of an infinitude of universes quite like our own, except different enough that they're utterly sterile. We're just trying to explain this one universe, and to have to invent an infinitude of other that we're not using just to explain the one it's not a good bang per buck. But the idea of, well, there's no alternative, so it must be true, that's false logic, because who knows, eventually an alternative may come along. But if you can't rule it out, then you have to keep it in play until such time.
To John, the anthropic principle is not helpful. Like most physicists, he would prefer to find one final theory that explains all the apparent fine-tuning naturally. He is also not ready to rely on a multiverse to do the selecting. Yet, what happens if scientists cannot find that singular ultimate explanation, and at the same time question the multiverse? The problem gets worse. But when problems in cosmology get worse, I get happier, because that means we need better theories. The anthropic principle emerges from a sense, right or wrong, that the values of physical constants are fine-tuned within tight ranges, which is the only way galaxies, stars, planets, and people can exist. I meet a scientist who takes seriously both fine-tuning and the anthropic principle, co-author of The Fortunate Universe, Life in a Finely Tuned Cosmos, cosmologist Luke Barnes.
Luke, how does the anthropic principle relate to fine-tuning?
So I think of the fine-tuning principle as a selection effect. So to an astronomer, these are very, very common things to worry about. It sounds trivial to say that when you point a telescope at the night sky, you'll only see the things that are bright enough to see. But actually, astronomers spend an awful lot of their time worrying about this sort of thing because it has a very important effect. So if we see a distant quasar in the universe and you wonder, it's a long way away, it looks very bright, why are quasars so bright? The answer to that question is not because otherwise we wouldn't see them. That's the wrong sort of explanation. But if you're wondering why galaxies seem to get bigger the further away you look, that's actually just a selection effect. Even if galaxies were the same anywhere, the ones far away, you'd only see them if they were very bright. I think the anthropic principle is that sort of thing. If you had a population of universes out there with lots of different properties, and you say, what would I expect to observe if I was in one of these universes? Well, the universe has got to make the observer first. So you would only expect to see universes which made observers. That's on one level trivial in the same way that you only see things that are bright enough to see is trivial. On the other hand, if you have a model of the multiverse, it can really do some explaining for you as to what you would expect to observe in that multiverse.
Physicists are heatedly in dispute about the relevance or importance or danger of the anthropic principle. Some would say that if you invoke it, you are admitting defeat and you are limiting the capacity of science to progress.
I don't take that particular view because cosmology is supposed to be modeling the entire universe. And so you're always modeling a system that you yourself are a part of. And you can't pretend to be outside of that system. So I like to think of it as Frankenstein. We are not Dr. Frankenstein. We didn't build this lab and have it make some life over there. We're the monster. We woke up in a laboratory and are trying to work out how it made us. So thinking of the anthropic principle purely as a selection effect, it's unavoidable if you're doing cosmology.
In contemporary physics, how is it being used?
I think the main use is in the context of the multiverse. So whenever you have a selection effect, it's that there's a population and then there's a sample of the population. So there's all the galaxies, and then I take a sample of, not just a random sample, I take the brightest ones. So if you have a population, then a selection effect can tell you why your sample has a certain property. And we don't just pick one at random to go and have a look at, right? We wake up in one of these universes. Why does it have these properties? Part of the reason for that is because that was the universe that could make someone to wake up and have a look around. And I think within that context, the anthropic principle really does some explaining.
The anthropic principle is a novel way of thinking. It depends on fine-tuning, why else would we need it? And to remain within naturalism, it seems to require multiple universes. A multiverse provides an immense variety of universes, each with its own set of physical laws, so that the anthropic principle can then work its selection bias magic explaining why the particular laws in our universe seem so perfectly suited for us. What if there were no multiverse? Then we'd better find an ultimate theory that compels the laws as they are, or seek explanations beyond the natural. Regarding the anthropic debate among physicists, I see both sides. Don't cut short or impede the search for deep explanations. But at the same time, don't cut off clues or insights from new data. And to those who would recruit the anthropic principle to try to prove the existence of God, the fine-tuner, I'd say be careful, you may hurt your case. Finally, the term anthropic, meaning human, is indeed misguided. In the vast universe, there may be radical forms of life or kinds of observers. The anthropic principle, understood properly, can bring us just a little closer to truth.
For complete interviews and for further information, please visit closertotruth.com.